Hi guys, Dr. Diaz here again. I'm trying to do one of the problems from the review. I think it's like 10, it'll go 10, 11, 12, 13. It has like gazillion of parts. So let's look at this problem and let's read it here a little bit. It says an indirect object or portable object is 50 centimeters from a concave mirror of radius 60. So telling you the radius 60, basically telling you that the center of curvature C is equal to C. I mean C is equal to 60 centimeters or 0.6 meter. So that's telling you immediately how much is the focus. Well, it's going to be C divided by 2, so it's going to be what? 30 centimeters. So here, even that is not given the numbers, you can calculate immediately where's the focal length, or where's the focus, which is 30 centimeters from the mirror, and where's the object, which is 50 centimeters. We know the radial curvature, or the center is 60 centimeters, and the focus here is at 30 because it's half of the center of curvature, or half of the radius, which is 30. And they asking you the characteristic of the image, if it's virtual and inverted, real erected, real inverted, virtual erected, or indeterminate. Now, we have done this problem with doing ray tracing, so you more or less where it is. I'll show you in a second. And you know how the story goes. A ray that goes parallel to the optical axis, when it hit the mirror, it will go through the focus. And here we have the first ray. Ray that it goes parallel to the optical axis, when it hit the mirror, it goes back and it goes to the focus, and I keep going all the way. Right. Now, the next one, we can use the one that it goes from the object through the focus. When it bounces back, it will go parallel to the optical axis. Now I'm going to draw this one in a second. And now a ray that it goes to the focus, like this one, when it goes to the focus, when it hit the mirror, it will go parallel to the optical axis, and then keep going here, and then keep going here, and then keep going here. And look what happened here. Here, this point is where both objects intersect. And here, where's the image is going to be formed. And you can see that the image is what? Is real, because this is a mirror. The concave mirror is forming at the same size of the object, but is what? Is real and inverted. So the right answer, correct answer will be C. See? Yeah. Okay, let's see the other questions about this problem. Oh, I forgot to say that characteristic would be is real, inverted, and much bigger. Okay, now let's try to answer the other questions from this problem. I think 11, 12, 13, 14. Now continuing with the problem. Question 11, it asks you what the distance of the image from the mirror, the thing that we just made by using ray tracing. They want you to calculate it, and you know, by looking, if the center curvature is 60 centimeters, it looks it's a little bit more than 60, probably 70 something, probably 80. I would say it's like 75. Oh, yeah, it makes sense that this should be the answer. Well, these doesn't make any sense, but it has to be 70 because we already said that the center curvature is 60, the image is at 50, so here it has to be a little bit more than 60. But let's calculate this one. Here, the thing is, on the test, I used to ask you guys to measure the distance. You know, I give you a paper, you measure those distance, and you more or less tell me with certain precision what exactly is that image by measuring. I'm not sure how I'm going to do it on the test, but probably I will ask you to do that thing too. But here, not only you can do ray tracing and you can see it's more than 60, you can calculate it by using the equation of focal length, solving for the distance of the image from the mirror. And I'm going to write the equation here in a second. You remember the equation for focal length is 1 over f is equal to 1 over s over 1 over s prime. We're looking for s prime, distance of the image from the mirror. So solving here, we will get something like 1 over s prime is equal to 1 over f minus 1 over s. Sorry about that. And now finding the reciprocal, we will have that s prime is equal to 1 over f minus 1 over s, which it will be, if you use the equation, it will be something like this. Let me do here. You will end up something like this: f times s divided by s minus f. Not like this one. Well, we have to find here common denominator. Then you know this is going to be an s, this is going to be an f. when you do a reciprocal, you end up with something like this. If this confuses you a little bit, guys, this equation here is fine. And if you substitute the numbers here, you will get what? 1 over the focal length. We calculate, well, it was given. Oh, actually, we calculated because we know that the center curvature was 60, so it's going to be 1 over 30 minus 1 over what is the object, which is 50 centimeters. And if you do this, you get an S prime, and I've rewrite this equation so it looks nice. If you do this using your calculator, you will get is 75 centimeters. Aha! So this the image is actually 75 centimeters, and if you look at our diagram, the one we did with ray tracing, yeah, it looks like it's we know at least it's more than 60. Well, this is not exactly, but at least, but because I mean I did this ray tracing here a little bit crappy, but at least we know it's more than 70, more than 60. It's like 70, like 75. So this actually number makes sense. Yeah, perfect. Now the next question is what is the magnification? And if you remember, I give you some equation for magnification. I'm going to write those here in a second. And those were n magnification is equal to minus s prime divided by s. And if you substitute here, s prime is what? Minus 75 centimeters divided by where's the object, which is 50 centimeters. And you will get a magnification of minus 1.5. And you remember, the reason why it's negative is because the image is inverted. And if we go back to the image, let's go here. There it is. Haha. And actually it looks bigger. If you remember the characteristics, bigger, rear, and inverted, yeah, it is bigger. So yeah, and it's like, well, 1.5 times bigger. So here we have magnification. Now let's do other calculations. Well, now these questions is telling, and the new question is, if the objects move to a new position such that the lateral magnification is 2.5, we move from 1.5 to, negative 1.5 to 2.5, the new object distance in centimeters closer to, okay, so we need to know what is m. N now is equal to 2.5, and we know that the equation for magnification, m is equal to minus s prime divided by s. So somehow we have to work a little bit with this equation and try to find where is this new object. So here I'm going to put some of the equations. Okay, so these are the two equations. Well, the only equation we have right now, magnification is equal to s prime divided by s. Now we know we have a new magnification because it's the object is moved where the lateral magnification now is 2.5 positive. They're looking for where is the new object. What about where is the image? We have here two unknowns, but if you remember a moment ago, we have an equation for calculating the image, right? And it was one of those equations that I said if it causes you confusion, I just avoid it. It's actually this one. Look at that equation. If I wrote it here, s prime is equal to f times s divided by f minus s minus f. Why I like this one, and actually if you can do the math, if you remember, you only have to do is multiply this guy by s, then you have s here, and then this guy by f, and this f here, and if you find the reciprocal, you will have fs divided by s minus f. Why I want this one? Because here, remember, we have two unknowns, the distance of the image and the distance of the object, and they're looking for the distance of the object. So it's a little bit difficult having two unknown and then only having one data, and then you have to solve for this one, because ideally you would say, okay, well, s it would be equal to what? S prime divided by m. That's it. But we don't know how much is s prime. But look at this equation. We have s and f, and since f is the same mirror, it hasn't changed, the focal length of the mirror is going to be always the same, because the same mirror is going to be 30 centimeters. So we know that one. So what we have here in the equation is we get rid of the s prime, which is another unknown, and we write this in terms of the equations that we know, which in this case is the focal length, and s, which is the one we're looking for, right? So now, substituting this s in this equation for s prime, I'm going to write here a little bit this thing in a second. And look what I did. I put here m is equal to minus s prime divided by s, and I'm going to substitute s prime, which is all this here. So I will have minus 1 over s, and now substituting s prime, I get this f times s divided by n s minus f, and you can see clearly that this s and this s cancel. So the only thing we have here is going to be minus f divided by s minus f. So now we have m is equal to minus f divided by s minus f. We multiply across this fellow, this direction, and then we have something like m, I should write a capital M. Well, we multiply m times s minus f is equal to this. We distribute the m here, so we will have ms minus mf is equal to f. We send this fellow to the other side, so we will have ms is equal to f plus, now is mf. And now we divide. Oh wait, there's this is minus f, I forget, because this is minus f. Don't get rid of the sign yet. Then we divide by m, and we would have, then what we do is we substitute 30, which is a focal length 30, and as a negative sign, it's going to be minus 30, plus n, which is 2.5 sine 30 divided by 2.5, which is m. And if you do that, you're going to get 18 centimeters. 18. And because the units here of the distance is centimeters, 18 centimeters. Oh, so that means that the image now is at 18 centimeter. And let's go back here to see what that be. Okay, yeah, here it is. The answer will be A. And what is that then? Well, in the image, 18 centimeter will be somewhere here, right? Somewhere here. And then in that case, you will see, well, we need to know, well, 18 centimeters will be where you put in the new object. That's why in this case, we haven't calculated naturally the object, I should say, is here in 18 centimeters. Okay, so the object is in 18 centimeters. That's what we're looking for. Okay. Where is the image? We don't know, but we can calculate it now with this one. If the question is asking, then the question is asking us to do that. Okay, let me see this in a second. Oh, actually, well, the problem is not asking to calculate that thing. But anyway, if the object was here, you know that the image is going to be formed on this side. And it's going to be bigger and up. And actually, that makes sense. Because look here, they're telling you that the lateral magnification is positive 2.5. That means it's in the other side and it's upright. Yeah, perfect. Okay, guys, I hope this helps a little bit. If not, send me emails and ask me, and I can explain this one again next time we meet on Wednesday. Take care, guys. Bye.